Centrifuges are widely known across the world. It puts an object in rotation around a fixed axis by applying a force perpendicular to the axis of spin that can be very strong. Centrifugation is a process where the centrifuge will separate components of a complex mixture. We have six types of centrifuge, which is microcentrifuge, small benchtop, general purpose, large capacity, super spin, and also ultracentrifuges. Centrifuges will move the denser substances outward while less dense substances move to center. The big issue here is centrifugation is inaccessible in field conditions. This is because conventional machines are huge, not affordable, and require electricity. So many researchers try to develop a non-electricity centrifuge, but the design produces very low rotational speed. So our objective is to create a low-cost centrifuge made by scrap from home and purposeful. By this, we could overcome the issue and produce a hand-operated centrifuge with high RPM.
Concept of centrifuge. A centrifuge is a piece of equipment that puts an object in rotation around a fixed axis, applying a force perpendicular to the axis of spin that can be very strong. The centrifuge works using sedimentation principle, where the centrifugal acceleration causes denser substances and the particle to move upward in the radial direction. At the same time, objects that are less dense are displaced and moved to the center. In Newtonian mechanics, the centrifugal force is an inertial force that appears to act on all objects when viewed in rotating frame of reference. It is directed away from an axis which is parallel to the axis of rotation and passing through the coordinate system origin. To an observer in rotating coordinate system, however, the effective force on the particle is given by the equation below. The first term, F, is the sum of forces acting on the particle as measured in the fixed inertial system. The second and the third term result because of the translational and angular acceleration, respectively, of moving coordinate system relative to the fixed system. Quantity negative m omega cross product with omega cross product r is the usual centrifugal force term and reduced to m omega squared r for the case in which it is normal to the radius vector. Note that the minus sign implies that centrifugal force is directed outward from the center of rotation. For liquid, the mass of the particle can also be represented as pi density times volume of the water. So density of the liquid can also affect how it's reacting to the force.
Came up with the oil-water centrifuge model. This model is hand-operated centrifuge and it is a relatively simple design with low-cost equipment found mostly in a regular kitchen. So let's get started. At this instance, we can see that water is propelled further outward because it has higher density. Oil with lower density rotated closer to the center of centrifuge.
Yes.
Two forces counteract the centrifugal force acting on the suspended particles are buoyant force and frictional force. Particles move away from the axis of rotation only when the centrifugal force exceeds these two forces, which results in sedimentation of the particles at constant rate. Oil and water do not interact with each other, so the difference in density will cause liquid of same density to accumulate and rotates with reactance to the centrifugal force.